This is the cool down for lesson 3. So this is called Some Are Translations and Some Are Not Translations. And lesson 3 is on grid moves, which are movements of an image within a coordinate plane or an isometric grid. And this is from Unit 1, Rigid Transformations and Congruence. And so for this cool down, the authors give you 1, 2, 3, 4, 5 images and asks you which are translations of triangle A, so which are movements of triangle A. All the points are moving in the same direction and the same distance. That is a translation. So let's look at B first. We're going to go from A to B. So from A to B, that is a translation, because if you notice, all of these arrows are the same length. This blue arrow is the same length as this blue arrow. It's a little bit behind the pink arrow here, and that pink arrow is the same length. So all the points on this image are moving the same distance, and they're all parallel. They're moving in the same direction. So that is a translation. How about A to C? So for A to C, this is a reflection. So the corresponding points are moving. So this point here corresponds to this point here. And the movement of that point is an equal distance from this line of reflection, which is the midpoint of this distance from this point in A to this point in C. So reflection is defined as moving in a perpendicular direction to the line of reflection. So this is the line of reflection. So moving in a perpendicular direction to that line and an equal distance from that line. So this arrow is the same length as this arrow. So this point is the corresponding point to this point right here. So the pink arrows, it's a perpendicular direction to the line of reflection, and it's the same distance from that line of reflection. So these pink arrows are both the same length. And this point here to this point all the way down here, those blue arrows are the same length, and they are perpendicular to this line of reflection. So this is a reflection. C is a reflection of A. How about A to D? This is a translation. Every point is moving in the same direction, so that's why these arrows are all parallel and the same distance. These arrows are all the same length. So moving from A to D is a translation of image A. How about A to E? This is a reflection. So the line of reflection is the midpoint, is at the is a bisector, actually. It's what they call that. It's the a line that is halfway between each corresponding point. So if I look at the pink arrows here, those are the same length, and they're a perpendicular direction to the line of reflection. So these blue arrows here, these are the corresponding points, same distance from the line of reflection and moving in a perpendicular direction. And this point here to this point all the way down here is an equal distance to the line of reflection, and it's perpendicular to the line of reflection. So two things to think about for reflections: an equal length away from the line of reflection and perpendicular to the line of reflection. And how about F? I had to make these smaller because this is a rotation, and you have to locate the center of rotation. We're going to learn how to do that the next lesson. But this is the center of rotation. So A is moving around this center. All the points on A are moving around this center to land at F. And that rotation, so every corresponding point moves the same angle. So the red angle here is on the outside, or on the inside here, and it's on the outside here. This brown leg of the angle, it's in the middle, and this burgundy is on the outside, and it ends up on the inside. All three of those angles are the same size. And the size of those angles, you can import a protractor into Docere and actually measure that size, and it is 45 degrees. You can see the 0 here and the 45 here, so that angle is 45 degrees. It's a 45-degree rotation around this center of rotation right here. This is the center of rotation, that point right there. And you can see in the protractor, this is about 2.5 degrees rotated from 0, and this is 45, 46, 47.5 degrees rotated from the 45 degree mark. So that brown angle is 45 degrees, and this burgundy goes through the 10 and the 55, so that is also 45 degrees. So all the angles rotate the same number of degrees, in this case 45 degrees, around this center of rotation, which is way out here.